we have come to a point in our linear algebra journey where we're using matrices. Oh yeah. Oh, this is some nice cinematic footage. It's like rotate around Pablo. When you think of linear algebra, do you think of vectors and matrices? I know I do. This is the set of what linear algebra is to me. I don't know why I'm in the set though. But oh no. If you follow Linear Algebra Done Right by Sheldon Axler, which is an amazing textbook by the way, you'll realize that what we're kind of doing is more abstract linear algebra. That's the fun stuff. No determinant, and he explains everything really nicely. First, let's listen to the lecture and take some notes. Professor Sheldon Axler provides an entire YouTube playlist for every chapter. This is why I'm using this textbook to self-study. Let's go. What's the deal with how we're using matrices in this textbook? It's a bit weird, strange, different, because you treat a matrix as an object. And the whole idea of algebra is not dealing with the actual matrix with the numbers in it, but dealing with the object called a matrix, and then defining the algebra around what you can do with that object. And then there's things like symmetries. So if I make this 3 of them like a triangle, how many degrees can I rotate it to get the same shape? So different kind of symmetries, that's an object, and you can define the algebra around it. That's called group theory, I believe. Yet to do it. Yeah, so algebra is really cool, and this is the real algebra, rather than what you do in high school, which is kind of just the rules for arithmetic, but abstracted. Yeah. Also, Pablo the penguin wants to say hello. Hello. He watches me. Very encouraging. Oh yeah, I apologize whoever's with me in my dorm, but I am buying a whiteboard for college, and it's going up in my dorm, and it's gonna be as big as I can make it. You can learn about all of the weird, wacky, fun, wonky multiplication, addition, subtraction, scalar multiplication of matrices by just Googling stuff. You can learn that stuff. It's easy. What I really want to talk about is what a matrix is and why is it there. Yeah. So we talked about linear combinations. Linear combinations, if you aren't familiar, you can read, if you haven't read the textbook, are when you have your variables and you multiply them by scalars, and then you add all of those together. That is a linear combination. Anyways, you can have linear combinations of a matrix. Your matrix is A, okay? By the definition, this is just x1 times A something something. So each variable is multiplied by each row column of your matrix. What this looks kind of familiar, right? Well, this is a system of equations. You got your variables. So if your matrix was, okay, so you got 3 columns. That's an A. You've got 3 columns. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Matrix. 1, 2, 3, right? This first column, all multiplied by x. So 1, 2, 3, x1 plus, and then you've got second column, so 4, 5, 6. You get a system of 3 equations and 3 variables. And then because we've defined matrix multiplication, everything to do with matrices abstractly, that also applies to systems of equations now. A system of equations is just a linear combination of vectors, and a linear combination of vectors is just those vectors stacked together, combined into a matrix, multiplied by the variables in your system of equations, which is just 2 matrices, essentially. So matrices kind of abstract the more messy looking system of equations, I guess. Now I'm gonna do question 1 of 3C if you're following along, and call it a day to do some programming, because as you know, that's what I do. I probably won't be sharing what I do with the programming today, although there'll most likely be an update tomorrow. Oh yeah. Oh, this is some nice cinematic footage. It's like rotate around.